Hi everybody, we're going to move into Unit 2, Lesson 1, and we're going to move quickly through this lesson and really jump into Lesson 2, which is more important to us right now. I just want to speed through this. We've talked about these ideas a little bit, and we'll talk a little bit more on Wednesday. Unit 2, Lesson 1 talks about a double number line. And this question is really just complete the double number line with the missing numbers, and what could each of the lines represent? I don't know if you've seen a double number line before, but we line up two number lines with different things in different places. So we have the first number line and the second number line, and those things that are on top of each other, those numbers that are on top of each other, they represent kind of like a scaled relationship like we've been talking about. So it looks like the top number line is twice as big as the bottom number line. 2 times 1, or 1 times 2 rather, gives us the 2. 5 times 2 gives us that 10. The question would be, what would go under that 7? Well, everything down below is half of what it is up above, so that would be a 3.5. Okay? It says, what could each of the number lines represent? Could be almost anything. I don't want to spend too much time on this. You could let your imagination run wild there. As we turn the page, we have this this idea of drink mixtures, which is really what I like to do in class, but we just don't have time this year. Usually I mix up some drink mixtures, and our recipes go like this. 1.5 cups of powdered drink mix to 1 cup of water. 1/2 teaspoon of drink mix to 2 cups of water, and 1/4 cup of drink mix to 1 cup of water. And what we look at is which one of those recipes would have the strongest taste. So we figure out these ratios by dividing. If I divide, what we do in class is we notice that these last two drink mixes actually have the same ratio of water to powdered mix. And if we had it in class, I'd have some red powdered Kool-Aid mix, and you could see that those last two mixes were a light red, one of them bigger than the other, but the same color. And that first one would be a much darker red. And I can't do different colors here. Anyway, the idea there is mixing drink mixes together, and the ratio of water to drink mix is what gives one a stronger flavor than the other. All right, this next page it's a nice little interesting question here about these 4 different crescent moon shapes. First question says, what do moons A, B, and C all have in common that moon D doesn't? And what we notice is that D is kind of this strange shape, right? A, B, and C are really kind of scaled copies of each other, we think, although because they're curved, we don't really have a way to decide that. So question 2 asks us, use numbers to describe how moons A, B, and C are different from moon D. So what I want you to do is pause here and draw yourself, because we can't measure again along the curvature, but we can measure a width and a height. So I want you to draw yourself a little rectangle around each of these moons so that touches the top corners and the bottom sides. So just like that with each of the 4 different moons. And we'll call those the length and the width. So for A, for B, for C, and for D. So pause here, count those boxes for the length and the width for each one of them, and fill in the table. So I've measured them all, and I called the up and down way the length, although it doesn't really matter which one we call this. I measured them all. I got the length and the width filled out in my table. And what I notice about A and B and C is if I divide the width by the length, in each of these cases, if I took my calculator out and I divided 8 divided by 12, I would get 0.6666 repeating. The same thing with B, I'd get the same thing, 0.6 repeating. Same thing with D, I'd get 0.66 repeating. Those are all the same. But if I divided in D, I would get 1.5, which is a different ratio. And that's what we're looking at in this unit, is those ideas of what happens when the ratio is the same and what happens when the ratio is different. So I want you to skip ahead to Unit 2, Lesson 2, and this is the most important stuff we'll do today. It starts with this question about paper towels, and it says, what do you notice and wonder about this chart? Okay, I want you to write down 2 things that you either notice or wonder on this page. Okay, and we can talk about those when we're back together. Now we're going to talk about this idea of feeding a crowd. It says, a recipe says that 2 cups of dry rice will serve 6 people. Complete the table as you answer the questions. We've been doing these ratio tables, these T-charts, all along. I want you to do as much of this as you can. So for question 1 and question 2, fill out the values in that table. What do you notice about going from one side of that table to the other? Can you fill out those values? I think you can, because we've been working this all year long. So pause for a minute and fill out that both of those tables. And then we get to this question, student facing this question about making bread dough. It says a bakery uses 8 tablespoons of honey for every 10 cups of flour. Some days they make bigger batches and some days they make smaller batches, but they always use the same ratio, and that idea of ratio is, again, huge in this chapter, in this unit. Complete the table. So as we look at this one, it's not as obvious what we're multiplying by to go from the left to the right or the right to the left. So what we can do is take our calculator and take those 2 numbers, and I want you to divide 10 divided by 8. And when we do that, it tells us what we're multiplying by to go from the left to the right. Okay, so do that out for me. Write that up here. It's times whatever number you get from your calculator. And then let's think of going the other direction. If we go backwards, we're dividing by that number, right? So fill out that table for me. Pause right here. Fill out that table. And then as we get back together again, the question here says, what is the proportional relationship by this represented by this table? They're looking for you to put this into words. They want you to say something like, there is a proportional relationship between the amount of flour and the tablespoons of honey. So we could say something like that. We could say there's a proportional relationship between the amount of honey and the number of cups of flour. We could say this table represents a proportional relationship between flour and honey used in the recipe. There's a lot of different ways to word that, but we want to be able to use that phrase, there is a proportional relationship. It just means that those 2 things are related through a common ratio. And then I want you to go ahead and answer the next question, the next table. And then we will finish out. And this one's important. It says what value belongs next to the 1 in this chart. And again, think of going, the 2 numbers that we know are the 10 and the 4. We divide to figure out how we're going from left to right. That value that's now next to the 1, as we divide that out, we get 2.5. That value is called something. It has a name, and that's one of the big takeaways from that. From this lesson, that value is called the constant of proportionality. Proportionality. And what it means is that for every quarter, we need 2.5 dimes to make the same amount. How do we get 2.5 dimes? Well, that doesn't make much sense, right? Because we can't have half a dime, you're right. Fill out the rest of that chart. And that's going to be it for today. We did a lot in one day. Tomorrow your homework will be to work on some of the practice problems from Lesson 1 and Lesson 2. All right, so have a wonderful Monday. Happy November. Bye, guys.